Hi, and welcome to the Azure Database for MySQL monthly webinar. I am Shreya Raital, and co-hosting the session with me is Avnish Rastogi. This is our sixth webinar in the series, and as always, we are live on YouTube, on LinkedIn, as well as Twitch. In case you missed any of our previous episodes where we covered some basics about Azure Database for MySQL Flexible Server, like our business critical queue, migration strategies, networking, security, and even performance tips and tricks, you can check out the recordings on our YouTube channel. Our handle is at Azure DB MySQL. So, in today's session, Avnish, do you want to give us an overview of what we'll be covering today?
Yeah, no, thank you, Sharia, and good morning, good afternoon, everyone. So our agenda for today is migration heavy. We will start with Partner Redapt, who will share their experience to migrate MySQL workload from Aurora to from Amazon Aurora to Azure Database for MySQL. They will share the migration tooling as well as tips and tricks which they learned from this migration experience. Then we will switch to our couple of product managers who will talk about MySQL Shell and how to use this utility to migrate MySQL workload from on-premise or from competing cloud to Azure Database for MySQL. And continuing with the migration theme, we will switch to Azure Database Migration Service, where over the last couple of months we added several features. So we will discuss those features. And finally, as usual, we will talk about the MySQL feature roadmap and some of the features we GA recently. Back to you,
Awesome.
Shreya.
Awesome. Thank you so much, Avnish. I think, yeah, but one thing before we get started, I do want to make sure is that we keep this session as interactive as possible. So if you have any questions or feedback at any point during the session, please drop it in the chat window and we'll address them as we go through the session. We do have two of our product experts, Sudesh Narayan Swami as well as Russell Green, on the chat to help address the queries. Thank you again, Sudesh and Russell, for agreeing to do this. Now, let's get started with the very first section. We are very excited to invite our guest speakers from Microsoft's Gold Certified Partner Redapt. Welcome, John and Chad. John, Chad, can you tell us a little bit about yourself and your organization before we get started?
No, absolutely. We appreciate the opportunity to be on and to chat with you guys. So over at Redapt, we've been in business for a little over 26 years now. We're providing both, Azure cloud services as well as some traditional data center build-outs. Redapt is a gold certified partner with Microsoft, and we have many specializations, not only in Azure, but in other, supporting technologies that are there as well. There's five main areas at Redapt that we support, in Azure. It's the cloud infrastructure and DevOps. We support digital and application innovation, data and AI, security, and managed services. So today, John and I represent the cloud infrastructure and the DevOps, where our main focus is really Azure Cloud adoption, including anything from building out the landing zone, security, governance, compliance, moving actual workloads into Azure, anything that's Azure native services, AVS, and even Kubernetes. We also specialize in many open source software solutions, including Linux and MySQL. So today, John and I will be sharing experiences we have with a specific customer, but we each have over 20 years in data center experience. The last 6 to 8 years have been focused specifically on Azure. John is one of our leading Azure architects, and so with that, he gets all of the complex migration projects that we get.
Thank you so much, Chad, for the intro, and thank you, John and Chad, for your continued partnership with Microsoft. Like Avnish covered earlier today, what we want to hear from you and share with our database, with our audience today, is your recent experience with migrating your customers' workload from AWS Aurora to Azure Database for MySQL. So, shall we start off with a brief introduction to customers' workload and architecture on AWS, and perhaps you could also give us a little bit of information on what was their motivation to move to Azure.
Yeah, absolutely. Let's start with a little bit of background for this customer. They were operating in the AWS environment. They had a pretty complex kind of build as you grow environment that was out there, and so a lot of moving pieces that connected together. However, they had more skills in Azure and the Azure infrastructure, and so they had a desire to migrate everything from AWS into the Azure environment. that's there. Now, this is still a rapidly growing company. They're constantly adding customers. They're adding, new product enhancements that are going on. They're adding additional databases as they're onboarding these customers. And so it was very much a migration while in flight kind of project. And so that's where a lot of the complexity came in, is not only simplifying the environment and giving them a better foundation for growth and scalability and security, but also to do it while they're growing themselves and adding customers in there. And this is one of the reasons why they had asked Redapt to help them with this migration.
Do you also want to talk about what were the instances? What was the workload size like on AWS?
Yeah, I can take that. So essentially, the front end of the application consisted of over 400 EC2 instances. Redapt migrated all these to Azure virtual machines, as well as 8 terabytes of file data that the customer had in EFS. But obviously, the database being the key component here, the database layer was 2 terabytes of MySQL Aurora spread across 764 different databases. There were over 238,000 tables in the environment running on multiple Aurora clusters. So the path of the migration was to migrate to Azure MySQL Flexible. The customer wanted Flexible Server to take advantage of the Microsoft management of the back end and still have that granular control and flexibility on the front end. The customer also has a high availability requirement that Flexible Server was able to meet due to the availability zone support. And then finally, the last advantage of Flexible Server was the read replicas, and the customer had a big desire to spin up read replicas to offload a lot of their analytical processing, in addition to having the cross-region disaster recovery.
Awesome. Read replicas, and I've said this multiple times in different forums, but read replicas is one of my favorite features in MySQL. So I totally echo what the customer's thought process here. But this itself was a fairly large and complex workload on AWS. So how did you migrate this MySQL workload onto Azure? Can you walk us through the process? And most importantly, what were the tools used, and how was your experience with it throughout the journey?
Absolutely. Yeah, so our first order of business was upgrading MySQL on Aurora to 5.7 so that we could move it to Azure. After we did that database upgrade, we did a database assessment and started performing multiple dry run migrations using the DMS, the Data Migration Service tool. And then at one point, we pivoted to using some native MySQL open source tooling that would be the MySQL dumper, MySQL loader, to try to accomplish the migration. We weren't able to find a lot of success using some of the open source tooling due to the size and the number of the database objects. So back in October of last year, we were introduced to the Azure MySQL product team, kind of led by Avnish and Sai and Russell and Swikriti. They partnered with us. They provided us some PowerShell tooling, and they even rolled out some backend enhancements to the DMS service that allowed us to overcome their previous hurdles. The Microsoft team partnered with us hand in hand, rolling out enhancements to DMS that really allowed us to overcome each and every issue that we ran into. And fast forward to April of 2023, a month ago, Redapt worked with the customer for the final production migration. And thanks in large part to these DMS enhancements, and especially the hard work from the Microsoft product team, we were able to prepare the production database and have it replicating up to the second between AWS and Azure. So within the first 15 minutes of the downtime window starting, we were able to fully cut that database over into Azure.
Awesome. Thank you so much, John, for sharing this. Loved how we were able to do the production migration using DMS with barely 15 minutes of downtime. So at this point, I'm really curious to learn how was the feedback from the customer, and especially what were some of the high points or low points throughout the journey for you?
Sure. So if we looked at the customer's environment, they had a non-production environment that was very large, a lot more complex than the production instance was. So when we migrated this lower environment in February, we found that the data in replication of a database that size with that many objects and tables was taking way too long to get caught up in Azure. So we ended up doing a couple things. We scaled up the backend Flexible Server to one of the highest SKUs in order to give it a performance boost. That helped a little bit. And eventually we were able to migrate the lower environment. However, it took a good 18 hours to complete. That being said, the customer was concerned going to production as we didn't have the luxury of 18 hours. I mean, this is a customer-facing application that runs 24/7. So the customer requested as little downtime as possible. Redapt again then partnered with Avnish and team, and we perform multiple dry run migrations, noting errors and recording timings. And due to this extra effort, we were able to cut the production database over in 15 minutes. So the customer was extremely happy with the outcome of the production go live. As strong Microsoft partners, we really enjoy the opportunity to work on enhancing the customer experience with the Microsoft product team and support making a better overall experience for sure for everyone using the tools.
Really great to hear this, John. And we really appreciate your partnership and any opportunity we can get to enhance our customer experiences, be it our product or our services, right? And thank you for your candid feedback throughout the journey and your wonderful collaboration. But one last thing before you go, can you share some tips or best practices that our audience could benefit from when they're moving to Azure MySQL?
Yeah, absolutely. So up until recently, a prerequisite for using DMS was you had to manually create all the required schemas in the target in Azure. However, DMS recently added a new feature that automatically creates the required schemas and database objects, the tables, events, etc. Now users have full control over which database artifacts to migrate with no manual effort required to create any database objects. For a minimal downtime migration, we found it most effective to seed the bulk of the database offline and then perform a bin log replication from the source. So a little bit of detail on that. When you perform the initial seeding, it's highly recommended to take a snapshot of the RDS instance and take the initial export off of that snapshot cluster. Once the data seeding and the export is complete, you grab the bin log position from the snapshot cluster, and then you read data changes directly from the master over to Azure using data in replication. If it's going to be several days between replication start and cutover, we recommend increasing the bin log retention on the source database. We used a value of 7 days due to the sheer size of the database. In flexible server, there's a couple parameters that we recommend. There's a max allowed packet setting, set that to the max, and then you can increase the parallel slave threads. That really helps with the data in replication performance. Another tip is, hey, when preparing for a migration using DMS, we needed to ask the Microsoft team to scale up the backend DMS compute to be able to handle the migration workload. By default, when you use DMS, it spins up a virtual machine on the backend, and you may not have all the specs that you desire. So with a simple support ticket, you can get that backend compute increased, and that really helps the performance. I think one of the key learnings we had when doing the lower environment, when you're running the data in replication for many days or weeks up until your cutover, ensure that you have a stable connection with good bandwidth to Azure. While the DMS tool does have retry logic built into it, a more stable connection, especially during the initial load, is going to provide you a much better overall experience. However, during replication, if you're using DMS for that and not data in replication, then DMS should be able to recover from a transient connection loss without issue. And the final tip, DMS does not migrate database user accounts from Aurora, so you need to recreate those database user accounts on the target server. However, it is possible to enable login migration from external sources like RDS using REST APIs or CLIs, but that's only if the authentication plugin used on RDS is supported on flexible server. So those are the overall tips and tricks for the community here.
Thank you so much, John. Folks in the audience, I hope you found these tips useful. If you have any questions for Redapt on their journey, or if you have any questions about DMS itself, do post them in the chat window, and John and Chad will be available on the chat for a couple of more minutes, and Russell from DMS is also DMS team is also available on the chat. So feel free to ask your questions on the chat window. But for now, there are no questions on the chat. So thank you again, Chad and John, for joining us and sharing your experience. And like I mentioned earlier, thank you for your partnership. But on to our next section, we'd like to invite Neil D'Souza and Rahul Saha to walk through how to migrate to Azure Database for MySQL using a native tool that is MySQL Shell. Welcome, Neil, Rahul. Let's start off with a quick round of introductions.
Hey, I'm Neil D'Souza. I'm a product manager for Azure Database for MySQL at Microsoft.
Rahul?
Yeah. Hello, everyone. This is Rahul. I'm on one of the growth product manager for Azure Database for MySQL. So welcome everyone to this webinar. So I'll be covering the migration demo in some time. So stay tuned.
Thank you so much, Neil and Rahul. So, in our January webinar, we covered migration strategies and tools used to move to Azure MySQL. Now, what I want to understand from the both of you, Neil and Rahul, is where does MySQL Shell fit in the whole migration scenario as a migration tool? What scenarios does it work for, and in what scenarios do we use it? How do we use this tool to migrate to Azure?
Yeah, exactly. So we'll be covering some of the aspects like for if you look at current migration strategies. So if you are migrating from on-premise or third-party cloud providers to Azure Database for MySQL Flexible Server, or from Azure VM or a single server on Azure to Flexible Server, we use different kind of tools for different scenarios. And now here we are just picking up from the this as topic covered in the previous webinars, where we showed how we migrate from these different sources to flexible server. And also if you are running on MySQL 5.7, how you can come to flexible server and then upgrade, or if you're already on 8.0, you can directly upgrade to 8.0 MySQL on flexible server. So we'll move on to the next one, where we will look at the different tooling that we have. So these tools are different, come with different experiences for different scenarios. Let's say, for example, offline migrations below database servers of smaller than 1 terabyte size. We use DMS, and for databases larger than 1 terabyte, we go for MyDumper MyLoader tool, which provide parallelization or multi-threading to speed up that migration for your large servers. Similarly, for online migrations, we have DMS with a built-in online option, and if we are using the MyDumper MyLoader, we combine it with data and replication to provide that minimal downtime migration. Now let's look at where MySQL Shell fits in. So it actually, the answer is it fits into all the scenarios. That's the beauty of it. And also this is one of the native MySQL tools, other than compared to the MyDumper MyLoader or MySQL dump, which is a single threaded so when we tested all these tools, we found MySQL Shell to be covering all the scenarios and does as good a job as any other tool. And combining with this, adding data in replication or the MySQL native logical replication, we can also do the minimal downtime migration, which is also the online migration. So let's move on to the next one. So here, like, what is MySQL Shell, right? So let's we'll have a demo covered by Rahul later on. So we'll take a look at some of the features of MySQL Shell, or what are the benefits of MySQL Shell. Let's go to the next one. So firstly, ease of use. So it's as easy as you're connecting to a MySQL server from a MySQL client. And it provides scripting capabilities using Python and some of the other scripting languages. And the best part is it provides parallelism for both dump process as well as restore process with the single tool, with good monitoring, good details of progress of what is happening in the backend. So you're not in the dark while the migration is happening. Multilingual support. Again, you can program using multiple different popular languages with MySQL Shell, like Java, JavaScript, and Python. And some of the advanced security features are also built into the product. And when it comes to scalability, be it a smaller database server or you are using a bigger database server, like more than 1 terabyte or even higher, maybe 5 terabyte, it is able to support those scenarios. So now I hand it over to Rahul to look at the syntax of this MySQL Shell and cover the demo of a quick migration demo.
Thank you, Neil. So here is a quick syntax. How do you log into MySQL Shell and the backup and the restore? So MySQL Shell, as Neil said, it's one of the native tools, and this can be used for backing and the restore process. So while you connect, when you want to connect to MySQL Shell, so the command is or the connection string is as simple as MySQL. So where like you need to enter like the username and the endpoint and the port number. So when you see the syntax, you can see after URI, you can see all the syntax similar to how it is like when you connect to MySQL. And the backup command. So once you log into MySQL Shell, and you can use the command mentioned here, and this can take the backup. And as you can see, first of all, there's a demo. I mean, there is a backup directory where you can mention where you want to take the backup, and you can use the thread. I mean, this is the parallelism which happens where you can use the thread. So it is as good as like how many cores you have in the CPU. So you can mention the thread, and it would do all the parallelism together. So, and the last command, which is restore, I mean, it is same, almost quite similar. You need to mention where was your backup, and you can also mention the threads, and you can, there's an interesting switch, which is like show progress. So here you can see where does the restore stands. I mean, you can see the progress from 1 to 100%. So I'll show you all these details in the demo in the next part. So yeah, everyone, welcome to the demo for the migration from like single server to flexible server using MySQL Shell. So I'm taking a small example from single to flexible, but it can be also used from different cloud or VM, and it can also be migrated to target server. So here you can see that I just took a snapshot. So what is my details of this single server? For example, there is a DB1, and you can see that the initial size of the DB1 is close to 8 GB or 7.68 GB. So we'll be migrating this mini amount to the flexible server in this demo. So once we understand, I mean, what to do next, I mean, so we'll be checking like we'll be logging to the MySQL shell. So the command, I mean, which we have seen in the previous part. So this command is quite interesting. I mean, because here there's a %40 included. So this %40 is very specific to single server, where I mean we cannot use @ 2 times in the command. So you have to use %40, which is an hash which is equivalent to @. So as you know, I mean, if it is a single server, you have to use @ and endpoint. So there is 2 @ at the command. So instead of that, we're using %40 as the hex command. So now we have logged in, and we can take the backup from this terminal. So the backup command which I've shared earlier. So here you can see the backup command which I've ran is quite simple, and it shows where is the directory where I've taken the backup, then the number of threads, and later at the bottom you can see the progress, how much is the progress of the rows, and what is the speed, and how much KB being transferred. So the backup is always faster, so the backup would continue. So for simplicity of this demo, I have just made it forward so that it completes. And so here you can see like how much time it took, and all the details related to the backup. And next we'll be looking where is the backup. I mean, if you have taken the backup, what exactly stores in the backup directory. So we go to exactly the location and check out what is the content of the backup. So here you can see there are multiple files in the backups, and we can see like which database have been backup in the JSON format. And then we can see the exact backup and the indexes which are involved. So all the details are mentioned, we can find in this directory. And there's a special file, I mean, @JSON, so which is inside this directory. So this gives details of like the binlog file position and the binlog file number. So these two details are provided, which will be later this can be later used in the replication process to have the minimal downtime. So next, we have seen the backup command, we have seen the backup directories. So it's very good to see how restore happens really. So as I mentioned earlier, our restore will be happening in the flexible server. So here we'll be first logging into flexible server and MySQL sh prompt, and then we'll run the command of restoration. So it is quite similar to the command of backup, but we need to already mention load dump and the backup directory. And so that's the location of the backup. So we have mentioned exactly the same location. And so we have mentioned the 16th thread, and you can see the backup, you can see the restore is happening in this process. So again, you can see lots of details here, for example, you can see how much being restored, what is the speed of the restoration, and what is the total backup size which is being restored, and what exactly is the speed, how much being speed, what is the speed of the restoration process. So this usually takes more than the backup. Restoration always take more time than the backup happening. So we can see that the restoration is completed, and we can see lots of details of the restoration process. So now we have taken backup, we have restored it to this flexible server. Now it's a time to create users. I mean, the special users, or if you have already created a user, so this user will be used for the replication purpose from single to flexible server. So here you can see the user is being created, and the special privilege which is needed. I mean, either it is like replication slave, which is being granted to the user, and we do a flush privileges so that the privileges are applied successfully. So this is how we created a different user which will be using for the replication purpose. And further in this process, we'll set up the replication now. So the replication, setting up replication, we need to do everything from the flexible server. But to do that, we need to get few details which I have seen early, like what is the binlog position, or what is the binlog file position, what is the name of the binlog file. So we get all the details of that, and we'll be logging to flexible server. And then there's a change master command. I mean, this is a stored procedure, and we mention the binlog file and the position, and we enter, so that the there's a success in setting up the replication from single to flexible. And now after this process, we just start the replication. So we again need to run a similar stored procedure, like to start the replication. And this starts the replication. And once it starts, so we can check the status of the replication using the native command like show slave status. And once we run this command, I mean, we can see all the output, and we can check what is being running. We can see like slave IO being running, which is like running, everything is running from source to target, and the SQL is also running, and there's no error during the replication. And the most important is the seconds behind master, I mean, so which is 0. So this is how we set up the replication using MySQL Shell. And it also helps in like cutting down all the time required for offline, and you can use this as an online replication with minimal downtime. So thanks for your time for watching this demo. Stay tuned for other things.
Awesome. Thank you so much, Neil, for the context, and Rahul for the detailed steps and demo. One last question I did have was, what about the performance? Is there going to be any increase in performance? The reason why I'm asking this is there are many other tools like my dumper, loader, etc., right, which perform similar multi-threaded migrations to Azure MySQL. So, what's is there a performance gain of any sorts?
Yeah, I can take that. So we actually tested multiple different tools. There are certain tools like MySQL Pump or MySQL Dump, which are only for dumping. And MySQL Pump has multi-threading capabilities, but for restoring, you have to use MySQL, which will again be single-threaded. So we compared the tools which can do both dump and restore in a multi-threaded fashion, which is MyDumper, MyLoader, and MySQL Shell, which we were able to do all these processes. And when we compared, we picked up some of the most common database sizes. One is 1 terabyte and 90 GB. And we also wanted to look at the number of database objects, like from 400 and 4,000. So in all these scenarios, we see the MySQL shell does better than MyDumper, MyLoader, and being a native tool with continued improvements from MySQL itself, from the open source community, we feel that this is a good tool for, and it covers most of these scenarios. Now, when we look at the restore performance, it is very, very similar. And in most of the scenarios, we saw that the restore performance also MySQL did very, very close or better than MyLoader, MyDumper, MyLoader. So that's the next slide. Yeah. So here you can see, like in most of the scenarios, it does better or it is very, very close to MyDumper, MyLoader performance. And so that's about it from my side. And
Thank you so much, Neil and Rahul, for the detailed walkthrough. So, folks, if you're looking for that, one tool that'll help you to migrate to Azure MySQL, irrespective of the scenario or the workload size, this could be that tool. So, it's that one tool to rule them all. Thank you so much again, Neil and Rahul.
Thank you, guys.
On to the third section. Avnish, you mentioned there were some updates in Azure Database Migration Service that you wanted to share today. Folks, while John and Chad did cover this briefly earlier today, for those who are unfamiliar with Azure DMS or Azure Database Migration Service, it's a fully managed service that enables you to perform literally end-to-end, seamless and automated migrations from most of the sources to targets on Azure. But over to you, Avnish, to cover the latest updates.
Yeah, no, thank you, Sharia. So to continue with the migration theme, as Sharia mentioned, and we discussed this in the previous webinar as well, Azure Database Migration Service is our first-party service, which customers can use to migrate different database workload from on-premise or from competing cloud to Azure. We support use cases like MySQL to MySQL migration, Postgres to Postgres, as well as SQL to SQL MI migrations. And we offer both Azure portal, which the GUI experience. So if customers are not comfortable with the command line experience, they can use Azure portal. And we also have the support for CLI or PowerShell in case customer wants to use the command line experience, or if they want to migrate large number of databases to Azure. It's extremely highly resilient and self-healing migration experience. So if there is a network glitch or something, DMS will continue to try, and there is no interruption in the migration. We support both offline migration as well as near zero downtime migration. So that's one of the common requests we see from the customer. And over the last couple of months, we added multiple features in MySQL migration use case. First is the support for CLI. So now on MySQL side, we have CLI support, which customers can use to migrate MySQL databases to Azure. And we also have a few option to select and migrate entire MySQL instance. Until recently, if you are trying to migrate all the databases within the instance, you have to select all the databases. And it was a bit cumbersome experience for the customer if you had hundreds of databases in a single instance. Now with this feature, you can simply select that option, and DMS will automatically select all the tables, all the views, events, logins, and everything, and does the migration for you. So it really provides you seamless experience without any manual intervention. And on the third feature, you no longer need to create the databases in the target instance. Once you identify the databases you want to move or migrate, it will create all the databases as well as the required objects and does the migration for you. And third and fourth, or the fourth and fifth bullet items is more about improving the user experience on troubleshooting different replication issues or migration issues, especially around replication and DDLs. So today, DMS doesn't support DDL migrations. So if there is a DDL transaction like create table, alter table, or columns, those sort of transactions on the source systems, we will show that information in the portal so that customer can take corrective action. On the replication side, we provide very comprehensive and concise information on the portal, and there is an option to navigate through different pages if there's a lot of information to share on the replication side. And if replication fails because of missing foreign key or duplicate keys, we also provide option. DMS will go into the troubleshooting mode and will start applying transaction one by one to identify where it really failed. And further, we will provide the command which customer can use to query a particular bin log file. And that will include both the start position as well as the ending position. So using that command, customer can identify which command really caused the replication failure. And we show only the table name and the columns. So we don't show any data for the privacy reasons. And finally, a lot of improvements on the performance side in our customer migrations. We have seen the improvement of 5x to 3x to 5x on the schema migration as well as data migration. So drastic improvement in the performance. And finally, users migrations. Now we support migrating users, both users with the password as well as without the password. So a lot of changes, lot of new features we introduced in DMS over the last couple of months.
Awesome. Thanks so much for sharing this, Avnish. But on to the final section then, a quick overview of our upcoming roadmap in Azure Database for MySQL itself.
Yeah, so we had exciting time. We recently GA'd couple of new features in Azure MySQL for flexible servers. So both data and replication using GTID based replication as well as on HA enabled servers. Both these features are GA'd now, and there are multiple features which we plan to GA in near future. One of them is Azure Database Migration Service for MySQL. So it's in public preview, but later this month this will be GA'd, and all the features I discussed in the previous slide would be available in the GA, including the CLI support. We also plan to have GA of major version upgrade on flexible server. So again, this is in public preview, but if customer has 5.7 and they want to upgrade to 8.x, this feature would be GA'd in May as well. And another feature which would be GA'd soon is a cross-region read replica on the paired regions. And a private link, that's one of the key features which is missing in flexible server, but available on single server. So we plan to have a public preview of a private link sometime later this month or in Q2. And with this private public preview, private link would be available across all the regions where MySQL service is available. In private preview, it's limited to 2 regions right now, but with public preview, we are basically extending across all the regions. And some other features which we plan to have GA soon includes MySQL extension for Azure Data Studio, connector for Power Platform and Logic apps, just to make sure that our customer can continue to get the value from the Azure ecosystem. And another missing feature we have is the cross-region read replica across all the regions. So that something would be in private preview in Q2, and then subsequent public and GA release. And another feature is auto scale IOPS. That's again planned to GA in Q3, so it's a bit far. And finally, Microsoft Defender for Cloud from the security point of view. that will be scheduled to have the private preview in Q3 2023. So these are
Thanks
some
so
of the features we are planning to. Really excited, and it's a busy time for our product team.
Thanks so much, Avnish. Again, calling out folks, if you want to try out any of the features in private preview, you can write to us at Ask Azure DB for MySQL at service@microsoft.com. Before we close out, I do want to call out the sessions we are presenting at two conferences this month. We are premium sponsors at Percona Live this year. Percona Live is one of the largest open source database conferences. Most of you may be familiar with it. And if you are flying down to Denver for this conference, don't miss out our two sessions and don't forget to visit us at our booth. If you haven't registered yet, you can still do that by navigating to percona.com live conferences, and you can also check out the full agenda on this page. Secondly, we are hosting a discussion session at Microsoft Build as well, which is our largest annual developer conference. So navigate to build.microsoft.com and register for our session today. Team, that's all we had for today. To learn more, you can navigate to aka.ms/MySQL resources, which is our one-stop shop for all resources. If you have any further questions, please feel free to reach out to us on this email ID, and stay tuned for more updates and announcements by following us on social media. Our handle on both YouTube as well as Twitter is at Azure DB MySQL. Thank you all for tuning in. We hope you enjoyed this episode. We'd love to hear your feedback on the session. So here is a link to the feedback form. And most importantly, if you have any requests or suggestions for the topics we should be covering in the upcoming sessions, or if you want to feature in one of the sessions with us, do fill out this form and let us know. See you all in our next session next month on 14th June at 7:30 a.m. Pacific time. Thank you.
Well, thank you, folks.